Hello there, and welcome to this Shieldier guide for the blue team perspective of the Damn Vulnerable web app. You will have to have, if you want to follow along at home, the blue team prerequisites set up on your host system to bring up the SIEM and to bring up everything else. However, if you just want to listen along, or watch along, or from some second monitor content, that's perfectly fine. We're going to, as we demonstrated in the red team perspective, we've used some shell, or in this specific instance, bash meta characters to escape the constructs of a specific command and execute arbitrary code or remote code execution on the Tartarus Damn Vulnerable web app instance. Here we're going to use, if you've been following the purple team perspectives, something that's just going to be making this a bit easier, nuclei, so you could then seed some of that data into the SIEM. I would like to just also point out, as is pointed out in the post, why not just look, like thinking of how to detect this activity. I was thinking, okay, well, we could look at the URL post parameters. Surely there must be something in there that we could look at and we could extract. No, there isn't. Surely there's some other means and ways that we could actually find this activity. Not that I could think of. I'm not going to be running the nuclei command because I already have the data in the SIEM, because I've ran this with a full blue team perspective. So what you're going to want to do, if you want to seed that data, run that nuclei command, and then that will put it into the SIEM for you. We're going to instead run some of the searches. So in the Discover tab, so just middle mouse clicking to open in a new tab for that specific link will open the Tartarus lab for you. We're going to look for this activity within, not the metrics, but we're going to look for it in the logs index. Here you can specify which index you're going to be looking in. Then I'm going to control V for that specific search. So we're going to say event dataset Apache access and URL path contains, for instance, exec or something that we've used to test, and it's not actually going to really find anything. We can look at if I move myself, we can look at the URL fields, and yeah, it's found that specific directory, but there's nothing else really here. There's some metadata, there's maybe the method that was used. Does that get logged? Yeah, the method post. There's the response body size, some status codes, log offsets, but nothing really that would indicate what is actually happening, the badness that's actually happening. So this is all to couch. There are some specific limitations when you're dealing with post requests. If we had a web application firewall, we might be able to inspect those post requests as they're happening on the wire. Or if you had maybe a big IP F5 or F5 big IP, you can then use iRules or whatever else to be able to intersect and intercept those post requests, the specific message body of the post requests. In the low security posts, we do not have access to that, so we must rely on something else. Here you can see the information that's being logged. If we want to take it a step further, you could even look in the Apache access logs. Here we see some post requests to the exec. As explained previously, the structure of these, we can see, okay, it was a Chrome user agent, but like there's nothing in there. What gives? What gives is it's not logged. There's not a zero zilch is actually logged in the post requests. Thinking then about the activity, what activity is happening on the server when that specific command runs. We can look at something like within Elastic, we can look at the event query language. In other SIEMs, there will be other ways and means for you to, hopefully, if it's robust, to look at this activity. We want to look at it via because we've deployed the Elastic agent onto all of these endpoints, that gives us another data set that we can use. You'll probably be able to do this in CrowdStrike or some other EDR. Here we can use the Elastic agent. We want to go we want to create essentially a timeline this would be under the security settings. Hide sidebar, thank you very much. So here under the, in the burger menu, under security, under timelines, we can now create a new timeline to search with the correlation or the EQL query. The specific query that we are going to run is something like this. So we are looking for where process, the parent process name equals Apache2, and the process argument regex is like this. These are all of the meta characters that could have been used in these instances. We want to then go command. So this would give us the process command line. We want to then add it as a column, and then it should, we can see here the command lines for, we want to actually search for this would be the latest commands. So you can see, I don't want all time, I want today, let's say the last hour. Then that would give us the information that we're looking for. So you can see netstat.a, so these were all of the fuzz commands that were attempted, and then all of the other sort of fuzz commands. There's some, again, more stuff from the fuzz, which we're not really interested in. But those are some of the commands that had been successfully run on the server. Now it's a bit difficult here to discern which succeeded and which failed, but this we know would have succeeded and ran correctly, which is the LSAL which we attempted previously. We can then inspect that specific execution with the box over there. This is one of the analyzer, one of the acquisitions that they've got. We can see, okay, Apache 2, which is the web server, now has executed this ping script. No, that's not the one we want. We want the other one. In our correlation, we want one that we know actually returns something, which would be that there. So you can see here, sh, the shell, has executed this ping c4ls. So this one would be the ping, and then it gives you some argument information, and then this would be another sh. So then this is giving you information as to what commands were undertaken by that specific process. Now you can a bit more easily see some of the threads that were tied together. We can then incorporate that into a Sigma rule. Here it's a very simple, as explained before, the metadata and stuff. We're going to look at the detection, the selection parent. So this is going to be a 2 conditional rule. We're going to say the process creation category is very important to set correctly here, and then the product being Linux. We then select set the detection to be the selection parent process, which is the parent process name Apache 2, and then the selection arguments for the command line for what's ran, command, and then re for regex, and then that specific string there to look for any of the meta characters. Condition, then we say selection parent and selection args. You could probably say all of selection underscore star as well, but this is just a bit more explicit. So it has to meet these 2 specific conditions for the search to actually run. False positives unknown, level high. We can then look in the alerts section for any of those Sigma alerts that have fired for activity that we undertook previously. Yep, there you go. Lots of detections. Now in one of these, you can, because we're using the event query language, you get access to the analyzer, and then you could just hit it with an analyzer and then look at specifically what's happened. So here it's running the dir commands to list the directories, and you can close analyzer. And then that's another way just to look at this activity. Moving on to another rule, another Sigma rule, we can also detect the reverse shell activity that's taken place. Here we can see, instead of looking for the shell meta characters, we can instead look for, in a similar vein to how the audit D rule looks for this activity, via the user selection. So saying the username is www.data, the audit D rule does it by the UID, but this is the same principle. Then we're going to say command line regex contains the SHI flag. So this is also to exclude some of the stuff that the server is doing normally, which is running shell ping commands, which it really shouldn't. But we want to then exclude some of that and only focus on the actual malicious activity, which would be something like another regex shc, and then we make BA for bash optional. We then also say that it will end in sh and then any number of characters, then a escape, so that it's actually literally interpreted as the greater than or less than, and then again with the ampersand, it has to be literally interpreted as the ampersand, not as a meta character within regex, but we don't need to worry about that. And then any other characters after that, the dot star or like a grok greedy data. We do both of those, and then we say condition selection. Then we will see for the activity, for the reverse shell activity, we will see here an analyze event for that specific reverse shell type activity. If you want to do something more advanced like the Python stuff, to be able to change the shell and stuff, you can, but you can see here that this analyzed event process args that, with the parent being that, and then the parent of that being that. Very suspicious, very suspicious. And then you can trace back further to which parent process PID 1221 is, and then you can start to build a picture as to what is going on your server. The no SIEM kind of problem. This is to explain there are ways and means you can look for this activity without a SIEM, but it just becomes a little more complex. In regards to, you then have to use something like audit D with a very good rule set on your Linux system. For this example, I'm using the one provided by Florian Roth in his GitHub. It is a really good audit D rule set that they do maintain. We can't use something like the systemd journal because this type of activity isn't logged in the journal file. We want to then look for the execution commands. Now there is already a key for what we are looking for. You can hear just explaining the differences between the process and just explaining the difference between the process ID or PID and then the parent process ID, PPID. A note, PPID and PID don't survive system reboots. So that's one area where information may get lost. We're going to look at it through the command line on the specific damn vulnerable web Ubuntu instance. So from the shell you ran vagrant up from, you're going to run this command. So cd projects and then Tartarus, and then I'm going to run vagrant SSH damn vulnerable web app. This will then use the SSH key to log in. We can then clear the screen. Now we're going to do, because you need sudo permissions, an AU search for that specific key, and then this is specific execution, and then the specific key being detect execcv from the www.data user. Paste that in, and then these are the results. It's a lot of stuff. It's a lot of stuff. There's no way really I could put myself on the screen, but I'll try to grab from the top of the terminal. There's a lot of information here. It's very machine orientated. We're not going to worry too much. We're not going to worry ourselves too much about that. But for now, we can look at, for example, this one here. That does look like quite a big proc title. So that's probably one we're going to want to investigate. Let us have a look just briefly. Is there anything else? That might look interesting. Maybe, oh, there's these. That looks like to read the shadow file probably. But we're not gonna worry about that too much. Instead, we'll take, let's say, we'll take this one here. This, ooh, that's nice and long. Control Shift C to copy. Now, as explained in the blog, all of the different areas that you're going to want to be looking at. Here it's explaining how, like in the analyzer, you have the first process, so the parent process, the sub process, and then that gets broken down into, it'll always execute the ping and then that specific command that you're going to want to be looking for. So here in CyberChef, this has already got the recipe, it's already got that specific command loaded for you. But if you want us to look at another command, we can look at something like this, and then it's just in hex. That's all the what do the numbers mean? What do they mean? It's just hex, so we don't have to worry about that too much. We do the auto delimiter recipe from hex, then that will give us a sh ping that's always going to be there, and then this is the specific sub shell, reverse shell that we ran. Very interesting that we were then able to pick that up from the logs. We can then take that further and try to understand, okay, the logs that we're looking at here, that's now ran the specific reverse shell. What is the parent process for that command? So then to investigate further, we can look for what that specific parent process ID is. So it's not going to be, in this instance, 906. It's instead, when we look here, we can see the parent process ID for this is PPID 1221. So we want to see what that process actually is. So we can then do PSFP 1221. That is the Apache process. There you go. So now we can confirm that the Apache process has run this reverse shell on the system, just looking at the audit D logs. A very powerful piece of kit to log this specific activity. Again, doesn't survive through reboots. All those caveats in place. However, if the server's still running and you want to definitely make sure, oh, you actually are running a reverse shell, this is one way to do it. That a reverse shell is actually running on that system, that's one way to do it. Then we can look at the timestamp for the web logs if you wanted to. So we're going to take this and then just fill in the details that we want, which there'll be nothing for there. However, the Unix timestamp for the log that we were looking at is, it's a long one there. That's the Unix timestamp there. So we can take that and then paste it in and have a look at the surrounding logs. We can see a post request. So that is the post request that has then initiated this reverse shell. Then you can see, okay, it's from that IP address, and you can tie all these things together and go, okay, now we have a bit more of a story as to what has happened on the server and how they were able to spawn this reverse shell. There's some more advanced things we can do, which we're going to do in the Medium post, looking at timings in regarding to network connections. Because we have a firewall, we may as well use it, but that's a bit more of an advanced topic that we're not going to be covering in the LoSec. Then finally, there is the purple team, which we'll get to in the next part of this video. I hope you've enjoyed it, hope you learned something, and thank you so much for watching, and I'll see you in the next one. Hello there, welcome to the purple team perspective of the Damn Vulnerable Web App Command Injection Challenge within the Tartarus Lab. If you don't have the blue team prerequisites installed for your host system so that you can bring up the Elastic SIEM and all of that, you would need that if you wanted to look at the logs and follow along in detail. If you do not want to follow along in detail, that's perfectly legitimate, don't worry about it. I'm going to cover the nuclei template that I've written to be able to scan the target for this specific type of activity. Moving on then to the Omega CLI and how we can then use that Omega CLI to both do the command injection and then have a multi-stage run where we can actually upload a reverse shell, catch the reverse shell, and then do all of that all in the terminal, all nice and easy, as simply as possible for you. So now we're going to have a look at the Kali instance and then run this nuclei command. You're going to need nuclei installed on on Kali, if you're in the Tartarus lab, it does not come packaged by default, but it's a simple sudo apt get install. The name of the package, in this case nuclei, will install it for you. And then all of the template files, if you're using the Tartarus lab, should be in the root directory for you, as in from the root directory in the Vagrant shared folder between the host and guest, in the nuclei templates, etc., etc. This template will enumerate the different ways and means to inject the meta characters and then output the results. Here we can see some of them have, quite a few of them have succeeded. So an input like that would all succeed. Looking at it to explain how it's doing this, again, the metadata as explained previously. Too happy with the clicks. Metadata, as I've explained previously. Variables, these variables are again used to define how we log in. You can use HashiCorp Vault or some other password secret storage facility. In this instance, it's just that vulnerable app. We can use admin password and not worry about it too much. However, that is a concern if you're in enterprise. Inputs, we're defining 3 arrays. The first is the IP addresses, if you want the command to succeed or fail, so the localhost IP address or ASDF, so that it fails. The escape chars, so an array of which chars we should be using. Commands, it's actually one command because we're using that output to be able to then facilitate the rest, the matching conditions, so the specific command that we want to run. Again, we're using the flow protocol, so flow 1 logs us in using 2 different requests here, an array of requests. You can say get, and then that populates the user token, and then you log in with the username being the variable we set above, and then the password being the password we set above in the variable section. And the user token then is extracted like that from the first request so that it can successfully tie the user token to the session. We then, the second part of this, so the double ampersand, the second part just sets the security to what we want, in this instance low, and then again using the token, which is a dynamic variable set here. We then, for the rest of the flow section, we do a for loop and we iterate over the inputs for all of the chars and then all of the commands. So there's only one command will be run, then all of the escape chars for all of the inputs. So it's a nested for loop in a sense. Then we set the specific HTTP that we're going to be using, which is this one at the end. We then say post, because it's a post request to put this data, the IP address. Here we then are then saying the specific input. We have to URL encode these things because some of them are URL unsafe. So we're using a helper function of URL encode and then the specific escape char from the variable array that we've set above. Then the specific command that we're running. Here, note, we're not doing any of the delimiters. The delimiters are this escape char that gets encoded in a URL safe manner. And then finally the ampersand submit and submit. We're then doing a match condition for the status to be 200 and then the word UID equals to be in the response body. Then that would indicate that we've successfully run the ID command like that, because it specifies UID equals. And we don't have to worry about that. Then we extract all of that information to be printed to the screen. As you can see here, that's the extractor at work printing what has succeeded, because it's got the response code 200 and it's got the UID equals. If this is what I've just gone over, then you can also use the Omega CLI, if you've downloaded it, to be able to do this automatically. We can take this for an example, and then going into the Omega CLI, again, you have to insert the specific API key into your local.m file. So do we have LL? Yeah. Okay, ls alh. So then your specific env file has to be inserted with the correct API key. if you're going to do authentication that way. If you're going to do authentication by username and password, it has to have the correct username and password. The env example will give you examples how you can run that. So here, this is the command that we're going to run: python 3 omega config to seed from the .env file, then the specific file that we're going to use for our template, then elastic local being the connector, and finally the target, and then the D flag for debug. Within that specific template file, it's then referencing the nuclei template to run with the nuclei executor with the executors directive. Here we can see that yes, we have successfully ran the nuclei template with these commands, and now we'll wait for data to ingest into the SIEM. Once it's ingested, then we can take a look at the alerts. So you can see here it's not being ingested within the first 15 seconds. Now it's going to wait another 15 seconds before trying again. There we go. So after about 30 seconds, all of the data with the meta characters has been successfully ingested into the SIEM, and then we can see these would have been the alerts that would have been generated. Again, we're hitting the preview API endpoint, so we don't have to worry about actually, we would be generating alerts in the SIEM. However, we're not directly generating them. It's just because we have to see the logs, etc., etc. We don't have to worry about that. Next, there is how do we effectively do this with a reverse shell. That's not a native feature to nuclei. It's very much not, what it's designed for. However, we can use it because it's just a web request at the end of the day. So why not run this specific nuclei template, which is the command injection reverse shell, and then we, with the executors directive, set a netcat listener to listen on port 443. So this would be a command you can use to then run it with a reverse shell. If it takes a bit of time to load, it's just downloading the packages from Docker Hub, so the specific Docker packages from Docker Hub for you. We can then see here, this is with the debug flag. That's one of the commands you could run, is docker run network host, because it has to bind to the host address. And then the second command, first it then tests if the target is up. If the target isn't up, where's the point in doing any of this? So it'll just shut down. But if the target is up, then you could run this as well if you wanted to do in the debug mode, but this does it automatically for you. It says here, okay, the specific command that we're going to be running. Now we can see the reverse shell has successfully been picked up by the Elastic SIEM. I just had to tweak the rule logic a little bit so that it could look for either bash or sh successfully. So with that out of the way, that is all I want to discuss with you today in regards to the Purple Team perspective of the damn vulnerable web app command injection within the TaskForce lab. Thank you for joining me today, and I will see you in the next one.